Okay, let's go ahead and take a look at one more mass-to-mass problem, which is, again, what we did today in class. We see we've got a balanced chemical equation. We've got potassium chlorate decomposing into potassium chloride and oxygen. The equation that's been given to us is, it gave us 71.8 grams of potassium chloride, and it's asking us how many grams of potassium chlorate would have started this reaction. So as always, we're going to start by writing down what we're beginning with and what we're ending with. And next thing we're going to do is drop down. We've got to get rid of grams of KCl, so we're going to go ahead and drop down grams of KCl. Anytime you see grams here, guys, remember the only possible value that can go there is the molar mass. And this is where you've got to be careful that you calculate the correct molar mass. And in this situation, it would be 74.551. Remember I said we're going to round at the end just to make sure we're consistent with our answer. And the molar mass is always going to represent 1 mole of any substance. So we've got 1 mole of KCl represented by 74.551 grams. Next thing, we're going to get these moles of KCl to cancel out. So once again, we're going to drop down moles of KCl. And for most of you, this is where you've been getting stuck. You see moles here, but you don't know what goes up on top. And so the thing to remember is that at some point, we've got to transition to this new substance. And so this is what I always call the transition step. We're transitioning from KCl to KClO3, and we're going to do that with a molar ratio. So here we come up with KClO3. Now we see mole over mole means we need a molar ratio, and when we need a molar ratio, we look to the coefficients. So if you look at your balanced equation, you see that you've got 2 moles of potassium chlorate, and you've also got 2 moles of potassium chloride. Now let's take moles of KClO3 and drop those units down as well. And here at the end, you see grams over moles. Well, again, anytime we're looking for grams, the only possible value to go there is the molar mass. So when we calculate the molar mass of potassium chlorate, we get 122.548 grams. And as always, the molar mass always equals 1 mole. So once again, we're going to multiply straight across and then divide. If you look at your original starting substance, you've got 3 significant figures in that measurement. So that means that our answer also needs to be reported in 3 significant figures. So with rounding, that would be 118 grams of potassium chlorate. Remember, you have got to include units, and you've got to include what compound those units are referring to.